This is Amanda Sage. I'll be going over SSH for our last presentation today for ISA 4220, Professor Green's class, spring semester 2017. Alrighty, this slide I'm going to go over SSH in a technical aspect. SSH is an acronym for Secure Shell. You want to utilize port 22 to implement the SSH protocol. Secure Shell allows secure access to remote computers by using a secure tunneling method. This protocol also allows for a computer to log on to, into another computer remotely over a secure network. Secure Shell should be used to securely transmit and authenticate all transmissions that are sent over the internet. SSH should be the only protocol used to ensure all information is transmitted securely. FTP, RSH, and Telnet, and many others of the protocols that are out there should no longer be used due to their lack of security. When SSH is implemented and two computers attempt to connect with one another, they begin with the TCP/IP three-way handshake. Once communications are established and the session has begun, the Diffie-Hellman session key will be used to protect data by the use of encryption. This next slide, I'll kind of go over the SSH handshake, which includes the TCP/IP handshake. All right, now I'm going to go over the SSH handshake protocol that I was just speaking about. It goes through about 5 steps. There are some little things that kind of happen in between, but I'm going to just do an overview of this handshake. Step 1, the client sends an SSH request to a server. Then step 2, the TCP/IP handshake begins, and that's whenever the client sends out a synchronized packet over to the server, which is what step 1 was. Then the server sends back a synchronized packet with an acknowledgement, and then the client sends back an acknowledgement packet, and then from that point, that is whenever the TCP/IP handshake is complete and a connection is established. Step 3 is an algorithm negotiation, and key exchange is actually set up at this point. A session is securely set up once that is completed as a step 4. And step 5 is whenever the client, once all this is done, the client can actually start up their remote applications and work as they need to. All right, now I'm going to go over OpenSSH in a technical aspect. Basically, OpenSSH is what we are going to be utilizing on our Ubuntu servers. It is open source. It allows for a secure remote transfer of data from one location to another. It uses encryption. Passwords are secured whenever they are transmitted through this encryption. They no longer use Telnet and some of the other older protocols because these protocols do not allow for encryption or encrypted connections like the OpenSSH or SSH protocol in general. SSHD continuously listens out for client connections and sets up accurate connections. And it also does 3 authentication methods: plain text, password, public key, and Kerberos. Basically, the plain text is when unencrypted data is transformed and processed through encrypted algorithms. Public key is an asymmetric algorithm that generates both a public key and a private key. And Kerberos is authentication that uses tickets that allow nodes to communicate over a network that is not secured, so they may securely prove their identity to one another. All right, now I'm going to go over some OpenSSH hardening techniques. I'm going to first go over the do's and the uses and enables, along with proceeding on to disables and limits. First, you want to use Protocol 2. Protocol 1 is no longer really something you want to use whenever it comes to the OpenSSH. You also want to put a firewall on that port 22 to add that extra protection there. You want to utilize strong passwords. You want to also implement public key authentication, and you also want to implement a keychain-based authentication. You also want to enable a warning banner there. You want to disable the OpenSSH server, the .r host. You want to also disable host-based authentication and root login via SSH as well. You want to also limit user access and IP building.